Okay, this is our presentation for CRB936. Our group is Louise Miles, Bonnie Molyneux and Majuri Senarat. So we have decided to create a design challenge which we call the Egg Drop Challenge. We came up with the challenge that students were required to safely drop an egg from a given height without the egg breaking. The students needed to design a product with limited materials that was creative and effective in protecting the egg. We allowed students to choose their own materials from the provided list, and the parameters we decided on were a 3-metre drop onto a concrete surface, that the design must be creative and use a range of materials. The product must also be created within the time constraints.
Outlined below is our unit outline. So now we're just going to go through our design process. We started with the investigation process and we brainstormed some links to our product through real-world context. We came up with links such as paratroopers, hot air balloons, and the Mars exploration vehicle with airbags. We posed an inquiry question to the students, which was, how can we relate an egg drop experiment to real-world technologies? These are the materials that the students were given to choose from. We tried to include a range of materials. Okay, so let's move on to our design, which was the second stage of our project. When we were designing, we had to consider 3 factors, so the acceleration, air resistance, and ground impact. This was our first design, inspired by a parachute. We've labelled the design with key materials in this photo, and we'll go into detail with them later. This was our second design, and it was inspired by the hot air balloon. This was an improvement from our first design due to the results we got from our test, and we'll explain that again later.
So this is where we have our create stage of the process. Here's a photo of our first attempt, and you can see here that we used basic materials to create the parachute design, and these were the materials we've provided a list of materials that we've used in the process.
Ready, set, go! And then zoom in. It broke.
Okay, so that was a video of our first attempt. You can see in this video that the design failed to protect the egg and it broke. We found some strengths were that the product was small and used few materials, and from this we came to the conclusion that it was a weak design as it did not protect the egg and the parachute didn't slow the product down.
As the first test failed, we needed to redesign and reevaluate our choices. We believed our parachute could be improved, so we chose to use a balloon instead. We also decided to provide the egg with more cushioning to better protect it. Our process is outlined below, along with the materials that we used.
Oh, the egg survived, but it fell out.
Our second test proved to be more successful at protecting the egg. The egg didn't break, but it bounced out of the cup. We decided that this was a weakness, which we would need to improve on. Some strengths were that the cotton wool provided more cushioning for the egg, and the balloon did gain more air resistance than the plastic bag. After testing both products with the egg, we decided to redesign and create a new product using strengths from our previous designs. So our final design was inspired by the Mars exploration airbags, and that was so that the airbags cushioned the egg from all directions, and you can see the design there. This was our third and final design, and it looked like this in the end. Lots of tape.
Go! And it landed safely with the egg still in there. It's not cracked.
So this is the test of our final product, which was successful in protecting the egg. After we tested design 3, we evaluated our strengths and weaknesses, and we found that the balloons helped in slowing the egg down, and that the base cushioned the egg
and saved it from breaking. We also found that the egg did not come out of the product as it was in place between two sets of balloons, so that was a strength. We identified some weaknesses, such as the product size and the amount of materials used, so that could be a possible improvement.
Okay, so these are our 6 stages of product development, and just note that we created Design 3 twice so we could document the steps. So the next slides are just a quick overview of the stages of product development. So this is our first stage. Stage 2, preparing the egg carton. Stage 3 was getting the balloons ready. Stage 4, we're attaching the base to the balloons. Stage 5, we're attaching the balloons together. And the final stage was inserting the egg and securing the larger balloons to the base. So,
this is our implementation into the classroom. Looking at our strengths and weaknesses of the design challenge, we identified that the activity encourages critical thinking while stimulating creativity. Through real-world links, it motivated students by challenging their creativity. The weaknesses that we addressed were that if students were unable to use their creativity, all their designs may be similar. We also found that some materials were not environmentally sustainable. We found that by limiting the number of materials, the project could be more challenging, and we could also make more links to ICT. And these were our possible improvements.
We hope that this presentation was informative to you and you can see how to implement this sort of activity in the classroom. Thank you.